Momentum and impulse. 15 is just 15 and 16 are both pretty straightforward conservation of momentum questions with a bit about elastic and 10 kilogram carts going rightward. I'm not going to read all that. I'm just going to show you the picture that I've drawn that displays this. So 10 kilograms, this cart's going to the right with a velocity of 3 meters per second. This cart is going to the left with a speed of 2 meters per second. Its velocity is -2 because it's going left. We don't know the mass of that one. Then they collide, and after the collision, the 10 kilogram one has bounced back to the left, and it's going 1 meter per second, so its velocity is -1. And this cart has bounced back to the right, and now it's 4 meters per second. We've got to find first the mass of the second cart. This is the law of conservation of momentum. Sum of the momentums, like the total momentum before the collision equals the total momentum after the collision. And this is how you get the total momentum before and after. The little primes there stand for like after. And the mass isn't changing, so I didn't put any primes on there. So momentum is mass times velocity. This is 10 times +3. This one has a momentum of whatever its mass is times -2. Now this has a momentum of its mass times -1 because it's got a negative velocity. And this cart has a momentum of its mass times +4. So just doing the math here, these two things together add up to 40 kilograms meters per second on the left side of the equation. And these two bundled together give us m2 times 6 meters per second over on the right side of the equation. So m2 equals 40 divided by 6, 6.67 kilograms. And then there's a question about whether this is elastic or inelastic and what happens to kinetic energy, the total amount of kinetic energy. So a good thing to do is to think about coefficient of restitution, which is the separation speed over the closing speed. You compare the two. So this is moving to the right at 3 meters per second, and this is going to the left at 2 meters per second. So they're closing on one another at 5 meters per second. And in the end, this is moving to the left at 1 meter per second. That's moving 4 to the right. They're separating at 5 meters per second. So since the separation speed and the closing speed are the same, the coefficient of restitution is 1. And that means this is a totally elastic collision, and that means the kinetic energy is conserved. So we've got the same total kinetic energy before and after. And by the way, if you want that equation, I think I gave the general equation, separation over closing, but if you want to actually plug stuff in and not have it be tricky, I think it's VA, it doesn't really matter. I'm just going to write it this way, VA prime minus VB prime over VB minus VA. So you could use that equation. And I might have it backward. It might be VB prime minus VA prime over VA minus VB, but that would work also. As long as the order is reversed on the top and the bottom, and the primes mean after and the non-primes mean before, you'll get the right answer. But you probably don't need to do that. Most people could look at this and realize these are coming together at 5 meters per second, and these are going apart at 5 meters per second. That's all you have to do. Number 16 is the same except for what happens after. So the movements before the collision are the same as before, but after the collision, sorry about that, after the collision, both things are moving to the left at a rate of 1 meter per second. So that tells me they've stuck together. This is my math. This is law of conservation of momentum. I just didn't write the equation again, but I simplified it. The momentum of this is 10 times positive 3. The momentum of that is its mass times negative 2, since it's going left. The momentum of the 10 kilogram one is 10 times negative 1 because it's going to the left. And the momentum of the other one is its mass times negative 1. So doing the algebra, you get 40 kilograms equals M2. So much heavier. And I can tell this is inelastic because they're sticking together. There's no separation speed at this point. They're moving together after this collision. They come together at 5 meters per second, and then they both move to the left at the same speed. And if there's no separation speed, coefficient of restitution is 0, so this is totally inelastic. That doesn't mean there's no kinetic energy after the collision. It's just by that definition, we call it totally inelastic. And part C asks, what happens to the total kinetic energy? And we know some is lost because it's totally inelastic. But if you want to compare exactly how much it had before and after, you could use the kinetic energy formula. So I did that. 1/2 mv squared for this, plus 1/2 mv squared for that. And that comes out to 125 joules. And then since they're moving the same speed at the end, we could just imagine it's one thing moving together. So I did 1/2 mv squared for the total thing. So the total mass is 10 kilograms plus 40, which is 50. And this is their shared speed. So there's only 25 joules of kinetic energy after the collision, 125 before, a whole bunch was lost. That's it for those. But don't forget about this and this. Okay, I'm feeling now like I just didn't stick a lot of that in here. The only place I can think that it comes in here is in this one. But be ready to use this formula if you have what's given here.